Nice to meet you all. I'm Amit. I'm the co-founder and CEO of OpenOps. Stephanie, you now work for Microsoft. I started my career at Microsoft as a software engineer. And actually, I was lucky enough to be there just as the shift to the cloud started. So I got into Microsoft a bit before Satya Nadella did, the new CEO, and I saw the company completely shift from on-prem to cloud, and I was even involved in building some of the early Azure services. I'm telling you this just to understand the background and to understand what I'll be speaking of. I'll definitely be more, like my talk is more focused on how AI is going to affect software engineering and cloud operations and technical professions, etc. Because that's my past, that's what I know. I don't know the answers to the questions you asked, unfortunately. So yes, I was at Microsoft. I worked on a few services that ran on about $40 million a month in Azure spend, so quite large scale. And then I got to build on top of AWS a bit in Checkmarx and Autopia. Autopia, by the way, was a company that built control centers for human to control robots remotely. So humans and AI can collaborate, autonomous vehicles and humans, exactly connecting to what Stephanie spoke of. And yes, we started OpenOps because we saw that there are a lot of benefits to automation. And yet we found that in cloud operations, a lot of companies don't implement automation the way we would expect them to. And it seemed like everyone want to automate, but no one actually gets really good advancement on that. And we thought, well, at the age of AI, with everything that's going on now, we probably can do way more than we did in the past. So I think I'm like, if I refer to Stephanie's talk, I'm a bit more optimistic because I know that as an engineering manager, I constantly wanted to do about 10 times more than what my software engineers could do. So, and like, if we are becoming more productive, I'm sure I could deliver more. So, you know, I never think like that I will need to reduce my manpower. The opposite, I'll be able to output more. That's great. Yep. So this talk is going to be way more specific about cloud automation. I'm just curious, how many, raise of hands, how many of you would consider your role technical, like IT or DevOps or, okay, the vast majority, great. So those of you who are not doing technical roles, feel free to stop me to ask questions. I might assume that you know a term by mistake, you know, but feel free to ask. So we'll cover a bit about what automation can help with, and the examples, I'm sorry, are very specific to cloud operations, but I'll try to give a more general view as well. And we'll talk about types of automations that can help in the context of the cloud and how to use them. And then, you know, the most interesting thing, how AI will change that and what you can do about it. So that's the context of our conversation today. So let's start with the trivial question, why even automate? I mean, we could do everything manually, right? Like we can download and click on buttons and send emails and right-size resources in the cloud and fix configuration changes, etc. But the stats are kind of amazing. Like if you think of the situation in the world today, I'll give you two examples. One from FinOps, which is the discipline of optimizing cloud resources, so cloud financial operations. And the other is SecOps, the same for security operations. In FinOps, Gartner, like the leading research agency for tech and IT, estimates that about 32% of cloud spend today is completely wasteful. And if you think of that in the context of what it means for the world, like Microsoft, Azure, Google, right now, don't have enough energy to power their data centers, right? Like even when I was in Microsoft, we were told that Microsoft is negotiating with the government of Ireland on how much power can they produce? And these kind of things, these are the real problems today. Like, I think by now, this was like almost 10 years ago. Now I heard a statistic that about 40% of Ireland's power output is going to data centers. So it's quite incredible. Now to think that 32% of it is wasteful, and it's actually resources that are just misconfigured or oversized, and no one actually is using it, it's not giving the user any good experience, that's amazing. So that means, again, my view is that today we're not doing enough, right? So hopefully with AI, we can get it down to maybe 5%. Rather than 32%, because like this is just insane amounts of energy and budgets that are going towards that. And the same problem exists in security. And this is again like the kind of research I read, and it just blows my mind that I just remembered the number going forward. So in security, we have the damages from cybersecurity attacks in the world today, they are around $10 trillion globally, okay? That's again, an insane number. What's more insane, in my view, is that according to research by IDC, over 60% of attacks on organizations are based on vulnerabilities that the organization has detected, okay? And knew about, okay? Think of what that means. Like the 60% of cybersecurity damages can be attributed to vulnerabilities that were exploited that the organization knew about. So cloud operations is actually a real problem in the world, right? Like the fact we have visibility doesn't mean much if we can't actually take that into solving the problems, if we can't run operations to take what we see as detections in our security systems, in our FinOps systems, etc., and actually get that to action. And that's what we do at OpenOps as well. So automation, of course, can ensure that people are accountable and aware to all these problems that we need to fix. Just by the way, to give you an example, because what's a security misconfiguration that can lead to an attack, right? So if I have a database, and that database is the backend for, let's say, a system like Amazon. And Amazon keeps all the credit card information in that database. And now that database is open to the internet and anyone can access it. That's a security problem, right? Like that's something that will lead to attack, that will lead to financial damage, etc. These are the sort of problems we want to fix. So we want to ensure that someone is aware and accountable when misconfigurations like that happen. And we want to drive them to action. We want to inform them. We want to give them an easy way to fix it, for them to actually prioritize it, because in most organizations you have thousands of alerts like that. And we want to guarantee that we respond when incidents happen and reduce operational risks. Like we want to do all of these things to fix all these problems. But it's tricky because we don't always know how to fix the problem. And even if we know, we don't always know in a large organization who owns the problem, who has permissions to fix the problem. And a lot of the work then goes to finding the right person, talking to the right person, getting the right person to even act. And also, our systems don't necessarily talk to each other, right? Maybe I'm working on Dynamics 365, and that doesn't integrate with another system that I have in my organization. I don't know, let's say ServiceNow. Probably they do, but yeah, I might have other systems that it doesn't integrate with, and that also creates a challenge. By the way, not theoretical. The average enterprise uses around 700 software as a service products. So for sure, all these 700s don't integrate with each other. These are the sort of things that create problems that prevent us from actually running automation and really having everything, all the problems, even that we know of, solved. So what can we do about it? There are plenty of types of automation, but in the context of cloud operations, these are some of the more common ones. We need basically an evolution here, right? Like, in order to automate anything, we need to start here, right? We need to start by doing something with our hands. We need to start by really trying to fix the problem ourselves, even if it's inefficient, even if it doesn't scale. We need to do it because that's how we learn what we want to automate. But then we have a lot of tools, like, so auto-scaling is a way for resources to right-size themselves and scale up and down based on the need. And we can build policies. There are plenty of systems today to build policies on top of the cloud and say what's allowed, what's not allowed, and both detect problems and even prevent them from happening. Policies are a bit limited, though, because they are condition and then action. And what if I want something more complicated than that, right? Like, what if I have an entire workflow where I need to collect data from various sources and then, like, make couple of decisions one after another, a couple of possible branches? That's where a policy wouldn't fit. But then, that's where software engineers come in, and DevOps and IT, etc., and build scripts. And I think one revolution that started a bit before the AI revolution was also the no-code, low-code tooling revolution, right? Which is essentially a next step in programming, as from the, I think, 50s and 60s, we have been progressing in our levels of abstraction, right? So we started with punch cards with like zeros and ones and machine code, and then we moved to assembly, and then to C# and Java, more high-level languages. C++ and C were in between somewhere. And now no-code, low-code tooling also really helps, because that brings in a lot of integrations, and it allows us to connect them into workflows and automations and basically abstract a bit more and give us like a visual representation of the automation that will run. So all of these tools were, if I was doing a presentation about this subject 3 years ago, this is where I would finish my presentation, and that's it. But of course, today we have a bit more. But before we continue, another big consideration when we speak about automation is the risk. And that's something that we don't always think about. Like, you say automation, you say risk. How are these two things even connected to each other? And the thing is that when we automate something, and that has to do a lot with AI as well, as Stephanie mentioned, we lose control, right? Something is going to happen without us being involved. And that thing might be dangerous. So, for example, we can decide that we would shut down every database that is open to the internet because it's risky, but then we'll discover that actually that one database was supposed to be open to the internet, and now Amazon, the entirety of Amazon crashed because we closed it, right? So that carries risks. If we define our automation in a way that is not optimal, we can maybe catch 95% of cases, but then 5% of cases might actually cause us harm. So there's risk for that. And that's where, in engineering, we have a lot of considerations on when to build automation, when not to build automation, when to add a human in the loop, when not to add a human in the loop. And in general, like, you can see a lot of consideration here that can help with that. But that's another thing to consider. Whenever we want to apply automation in the workplace, we need to consider the risk. We need to consider how tolerant is our organization to risk. And actually, that's a very big leadership challenge as well, because if you want to enable that, you need to allow your people to take risks, right? And that's a hard thing for every leader. That's actually where our natural concern and care conflicts with letting our people innovate and letting our people like really build things that make the business more efficient. So these are some examples that are more relevant to the technical people here. But in every form that we can think about automation, we can think about low-risk activities and versus high-risk activities. So an example for low-risk activities in the cloud are, for example, modernization. Like if we want to take basically old generation of disks and replace them with newer ones. Maybe Silk, you do that automatically, right? So that's like a low-risk activity because typically you can do the swap in a way that won't cause downtime, won't destroy your system, etc. On the other hand, if you have a production system and now you want to, for example, say, okay, this resource, like we said, 32% of cloud spend is wasteful. Part of it is like I have a virtual machine with like 32 processors where actually my application needs 2 to run, okay? But then if I do this correction, both I can cause downtime and I can degrade the performance because actually when I do that, suddenly it can turn out that what I thought requires 2 processors actually requires 4. And therefore it's a high risk activity. The good news is that we don't have to think about it as a black or white or yes or no question because automation can do a lot of things even if a human still needs to make the decision. For example, we can, as we said, create awareness, right? Let the engineer in charge know that there is a problem. That's already a good automation, right? Instead of us having to nudge someone else and maybe get them to become defensive, like we just send our bot to do that in Slack and send them a message every day, right? And that creates less conflict and allows us to focus on when we do talk to that person, we can now have a more friendly conversation and brainstorm together more advanced solutions. And we don't need to nudge them about like every little configuration change that they need to handle. So automation can come in even in high risk areas, but we need to think differently about what it does. We need to think about it as assisting the human who will make the decision rather than doing it all for him or her. Okay, so that's automation. Now, how AI is going to change that? So, agents can do a lot, and if you're not familiar with the term agent or with the difference between like a LLM and an agent is basically an LLM that is capable of breaking down request into a multi-step plan and to assess the progress of those steps and to get it to completion through not like a one-shot answer, but through a process. And agents can definitely help us observe and assess the situation, right? In terms of visibility, they can definitely help us with visibility. We can ask them questions, we can get great answers, and they can help us choose the path that we will take, like how to get from A to B. They can help us do a lot of things, and they can work 24/7, which is great. Great if we know how to use them. Not so great if they are doing this for their own interests. I hope we won't get there. But it comes with a lot of risks as well, right? Like, where's my risk slide? I don't have my risk slide. Never mind. Part of the risk is that agents and AI in general hallucinate. How many of you have already known about this problem? Okay, all of you, great. So, like definitely, AI, unfortunately, a lot of kids today, some adults today, use AI without knowing about hallucination. So they think it's like, a Google search which landed on the most reliable page, and actually it's not. So there's like a famous case that was published last week, where I don't remember which newspaper, but they wrote like an article, 15 books that you need to read at 2025. And out of these 15, 10 books didn't exist. but they made a lot of sense, right? Like the author was real, the subject was something that this author writes about, and and the description in the paragraph was also something that really makes sense for this author to write. So LLMs are really good at giving us an answer, just they are not always fully reliable. And in the context of the cloud, like think about that, like, including a database that shouldn't be deleted in the list of databases to be deleted is kind of a big problem, right? So we need to be careful with that. Now, okay, so all of you know of hallucinations. How many of you know what MCP is? Okay, very, very good, very knowledgeable audience. Anyone cares to explain what is MCP? Yes?
So basically, it's a standardized protocol to find how the agent should communicate to another agent. So previously, before MCP, everybody has to define their own custom tools to talk to agents. Now we have common protocol so that agent can talk to any using that protocol. So it's a layer of protocol.
Exactly. So, and A2A, by the way? Anyone knows A2A?
Agent communicating to each other rather than the model coming to the communication.
Yes. So that's something quite amazing. That's a big change in the world of engineering in general. When ChatGPT was released, we saw what LLMs can do, right? Now we are, and that's really a really recent development, like in the last maybe 6 months. We are starting to see market standards for LLMs to communicate with software and AI to communicate with AI. And that's mind-blowing. Like if you spend some time in IT or software engineering, DevOps, etc., for the last 10 or 15 years, you kind of think of the world in terms of services and APIs, right? Like we have services, they talk to each other through API, application programming interface. We have like calls with parameters. It's all like very accurate and neat, and it has a predictable result. And if you test it once, you'll do it again, and it will produce the same result. Suddenly, APIs are not the only interface. Like the model context protocol is just a way for a model to understand an API, right? So it's like literally giving the model context on how to consume an API. So that enables AI and traditional software communicating with each other. And then A2A is the other part of the equation because that enables agents to communicate with other agents. And this is incredible because this is going to unlock a whole world of productivity. Like companies like us now that are building software at this age are actually now able to connect through MCP and A2A to other agents, to other software, and bring a huge, huge, huge amount of value to the users through that. And this means we will start to see the effect of standardization in this case means we will start to see a lot of new experiences, and you will see quite soon, I'm sure, like in the next year or two, we will start to see new types of software that we potentially didn't believe was possible. And I think we already see that. I don't know how many of you use Claude or Manus AI or OpenAI Operator, like all these new agents. Some of them are really immature. Like, for example, I will save you the time. Don't try OpenAI Operator. It's not good. Like, I was kind of surprised with all the hype, like how bad is it? But it's not there yet. But at the same time, I'm sure it will be. At some point it will be. And other agents like Manus AI is my favorite for the last 2 months because it's just doing incredible work. I really recommend you try it. But Claude and Anthropic are doing amazing things as well. And really, we are starting to see, I think now Claude is basically the most advanced in leveraging MCP. MCP is by Anthropic. So you can already see how Claude can communicate with other pieces of software to find you hotels in Booking, to find you, to order food from Instacart, to order food from Uber Eats. Like it can really connect with a lot of other pieces of software. But now these protocols are being widely adopted. And actually, every startup, every company in the world will be able to build on top of them. So we're going to see a huge amount of these kind of products coming to the market, and as well for governing our cloud workloads and managing our technical operations and technology operations. So, for example, in our context, one of the things that we are working on right now, so we're building basically the Zapier for cloud operations, like a no-code, low-code engine to run the operations and gap the distance between having visibility and actually solving the problems that I spoke about in the beginning. Now, for example, we are not a cost visibility system. However, we can connect with our AI with the MCP for Amazon Cost Explorer, AWS Cost Explorer, and our AI can produce answers about Amazon costs based on their reporting through MCP, and it just works. Now, it's quite insane, and we will see these kind of products coming to the market. It's not only us doing it, it's the entire ecosystem is building products like that right now. So that's quite interesting. Yes?
I don't know much about MCP yet. So do they communicate in English or like natural speaking language? Or?
So I gave another talk where I said that AI agents talk to each other. And someone approached me and say, why do you say talk? It's not like they speak English, right? Like, actually, you know what MCP is? You need to describe in English the functionality of the API. That's basically it. Like literally MCP is a protocol for you to describe in language what your APIs do for the LLM to be able to understand it. It's quite amazing. Yes, I think, by the way, documentation is going to become so much more important because, if your APIs are not documented, LLMs wouldn't know how to call them. So it's quite interesting. Yeah.
So if we have documentation on APIs already, can LLMs not already read the endpoints and then figure out what the APIs are doing?
Yes, but
that's how MCP is that how MCP is working, or?
Yes, so MCP is like a more well-defined structured protocol to do that. And that's important because, because of hallucinations, because of AI not being perfect. So theoretically, and you'll hear a lot of stories about what AI could do. A lot of it is potential. It's not like the situation right now, right? So yes, you could let AI read the documentation on its own and call the APIs, etc. However, when you structure it, when you standardize it, when you train AI specifically on doing that with a set standard, then you get just much better results. So that's basically, I hope that answers your question. Yeah.
Can I ask a question? So
Yeah.
for mission critical systems, you are not supposed to make any mistakes. API cost, it's always, as you said, it always works. But for MCP, would it even if 1% or even 0.1% of error is it still an error? So would you say that MCP is reliable enough?
For sure, no. Actually, that's a great question. You know what's a great question? A question I have a slide for. So I have a slide exactly for your question, because actually a lot of questions remain unanswered. Like, how do we avoid hallucinations? Who will be accountable if that 0.1% mistake happens? Will enterprises that are regulated allow agents to change their cloud environments without knowing exactly the reasoning behind it? this is these are questions that are still unanswered in the industry today, and like that's where I say like AI has a lot of potential. We read a lot of stories on what AI can do. We read a lot of news articles about this CEO replaced his entire customer support with AI and things like that. Like if you'll go in actuality, like to enterprises today and look at their cloud environments, many of them are not using the automation types that I showed in the beginning that have existed for 10 years already. So like the reality and the vision sometimes have quite a gap between them. But in this context, I think like that even as we advance, these questions are still hard questions. And as you said, we need to understand that when we work with AI, AI is a statistical machine. It will produce the most statistically probable result, but it's not going to always answer all the edge cases. It's not always going to catch all the different problems that might occur. And that's exactly why my personal take is that we will proceed to progress in the level of abstraction because we will need to read more, but we will still want something that is stable and predictable, okay? So I think that AI will be very much used to understand the problem, to explore, to get ideas, to fix or make changes where there is low risk. But then I think that for making changes in actuality, we will still want a predictable recipe that runs and we can review. And once we review it, we know, okay, I approve this. Like a DevOps will still be required to approve something is going to run to change production configurations for a tier 0 service. Like it's not, I don't see this changing, not even in the next 10 or 15 years. Like I don't know to predict beyond that because, like I'm not even sure I know to predict 10 to 15 years. It's what I think. It's my personal take. We can meet here again in a decade and see if I was right or not. But this is what I think. I would love to hear, like, if someone here has other opinions and thoughts, like, yeah.
You had mentioned about earlier SecOps, especially in terms of vulnerabilities and all. So are the AI agents being used for red teaming, especially for identifying vulnerabilities, and how reliable they are to identify more and more vulnerabilities, especially for pen
Yeah.
testing?
Great question. So red teaming, for those of you who don't know, is the practice of appointing a red team that will try to attack our organization in order to reveal security gaps. I think this is a wonderful use case for AI because AI can definitely get creative and try a lot of things like attackers will do, because that's what attackers do, right? They try a lot of things and they see where they can get them in on the organization. AI can do that wonderfully. In fact, I already know entrepreneurs working on systems to build like an AI-based red team. So definitely this is a use case where AI can be very good. You just want to be careful that it's not like too good. Like you don't want it to actually manage to crash your organization when you don't intend for that to happen. Yes.
So you mentioned that AI, like LLM, they tend to hallucinate, and especially it can be a problem when it's sort of like communicating on the MCP. So what is your solution to it, since you have built a product around it and start selling it?
Yeah, so that's exactly why we, in our product, use the AI in order to explore and basically get information, brainstorm, etc. But then the output, as a cloud automation company, our output is a predictable recipe that AI will help you create, but you as a human still need to review, iterate on. You need to make it your own creation. And then in a sense, like we can think about it like generating images with ChatGPT or with Midjourney, etc. You start with a prompt, you get something, but then you want the colors to be different, you want the style to be a bit different, you want the character to have a different expression, and through this iteration, you actually make it your own. And this is how we see the world. We see, when you want to run cloud operations in enterprises on sensitive environments, you need, in the end, your output needs to be that predictable recipe that will run and automate things. And that predictable recipe can also include human approval in the loop. So a lot of what we do, for example, will include sending messages in Slack and asking the person in charge if, for example, we can delete that storage, or it will open a PR with a pull request, with a change request, suggesting the code changes that need to be applied, but still the engineer needs to actually merge these changes and push them to production. So this is how we deal with it. So we use AI for exploration, we use AI for understanding what you want to build, we use AI to actually build the workflow automation itself. However, you as an engineer still need to review it and still need to take accountability on running it in production. So it helps you be more productive, it doesn't replace you. Yeah.
Could I ask a question? I don't know if that's a business secret, but how much big the proportion is you are bringing the human in the loop? For example, your stakeholder might not be very happy if every step is asking for the justification or approval thing.
Yeah.
So it might cause a slow latency, which is not be very happy for the customer's perspective. Yeah, so I'm just wondering, how much the percentage of your flow task is going to be asked the human in the loop?
Yeah, so that's a great question. And I think that it all comes back to risk. So what we see our customers doing is in dev environments, for example, we see them being quite aggressive, doing a lot of changes automatically, running it, and if someone complains that something happened, then, it's a dev environment, it doesn't affect customers, we fix it the next day and everything is fine. And in production, usually our customers don't want to do things automatically. It's very, maybe 1% or 2% of our customers are that advanced that we will apply changes in production automatically without human supervision. So it's all based on the risk. And what we typically see is that most of our customers start with aggressive automations that are without human in the loop in environments that are not risky. Okay, that's typically how they start with, and then they gain confidence with the system and they start using it for more high risk changes as well. If that makes sense. Yep.
Can you give me more use case on how AI, why we need all of those agents you call the API? For us, we use for security we use Wiz, and for FinOps we use RTO, and then those already provide a lot of information for us. And then if you're just calling APIs, we can have a lambda function to just do that too. We don't need the agent to call those APIs. So not really understanding why we need those agents and stuff. Why is it better?
Yep. So do you use, for example, GitHub Copilot? Are you a software engineer?
I use it, but it's really slow. Not sure if anyone else knows it.
So actually our developers, and which all of them were small company, every person counts. So, all our developers have 5 years of experience at least. And we all use Copilot, and everyone are testifying that it greatly improves their speed. And then, if you're not happy with GitHub Copilot, there are products like Codium and other products as well, Cursor, etc., that really change the pace in which you write software. In a sense, I think that people 5 years from now will not remember syntax at all. Because it becomes redundant. You write a comment with what you want to build, and you get the code, and you iterate from there. So it's for me asking, why do we need autocomplete for function names? But once we had that, it became so much easier to write software. Many more people who are able to become software engineers. Now, when you look at SecOps and FinOps specifically, in a lot of companies you have also finance people that are involved. for example, in cloud efficiency, in resolving all these wasteful resources. And suddenly you can include them in the conversation as well, right? Because they have an AI that can explain them what this automation does. They have a higher level of abstraction. They have a pretty workflow that focuses on the business logic and not on the authentication and the API calls, et cetera, et cetera. They can understand much more. I can also say, as a security, I worked a lot on cybersecurity products, both in Microsoft and in other companies as well. I can say that even for myself, after I had like 5 or 6 years of experience, I would still look at certain vulnerabilities and I would be like, what does this mean? Like, I don't understand what this means. I don't understand how I need to fix it. And definitely, if I had AI at the time, I would definitely paste it to ChatGPT and ask. And I'm sure, and with prompts like, explain it to me as though I'm a software engineer that doesn't understand anything in security, explain the problem to me in a simple software engineering language, I would get an answer that I can understand. So I think it just enables more people to participate in the party, more people to build. And, you can see that we launched rockets to the moon, right? And you see how the code was written. It was written on pages that are if you stack them up, they are taller than me. And we used to write software like that, and we launched Person to the Moon. But how many people were able to be software engineers then? You needed to be completely brilliant to be able to build software then. And today, people with other types of intelligence, people with broader capabilities in different disciplines can now participate in that because of the higher level of abstraction and because of that help. So, yeah. Yes. Many questions. I don't know who to choose. Yeah.
A little bit about the risk, and I think from my perspective, for the risk to be manageable, probably permissions are probably which regards to authentication.
Mm-hmm.
So do you see that's already part of the current abstraction, for example, for MCP, or do you see it's going to higher abstraction?
Yep. So I think that the security, privacy, permissions question is a really important one. In fact, since I got to see the cloud being born in Microsoft, I know that when we started to move everything to Azure, actually that was the biggest customer concern. Enterprises wouldn't adopt Azure because of concerns on permissions and security, etc. And I think that definitely we are in an age where that is not mature enough, right? We don't know how to train models, but still protect the data, have them learn from that data, but then we don't want the data to be accessible. I think that there are many, many questions here. And I think the level of maturity here is such that, I wouldn't necessarily, build solutions like that on my most sensitive data right now. But at the same time, this is required for companies to really adopt it. This is required for doing business. So all the hundreds of billions of dollars that are going to enterprise AI products right now, to building, to R&D for enterprise AI products, etc., are not only going to train a smarter model. They are also going to that, to building better privacy, to building better security. And by the way, this is a educational deck. I didn't mean to talk about OpenOps at all, but this is exactly why we also opened the feature. Our product, our entire core is open source, and we even opened now a feature for you to connect your own AI to the system to generate workflows. So you don't need to consume our models. You can do that with Claude or ChatGPT. One of our reasons was exactly that if an enterprise already invested in security and privacy controls on top of AI, we're not going to be able to compete with that. And therefore, if we don't allow them to bring their own AI, we're blocking ourselves out of the party because, we will not be able to build models with such security controls, etc., at this phase of the company, at least. Yeah. Yes.
This is probably a redundant question, curiosity rather, but wouldn't with abundant compute, we'll be able to fact check, or make it more predictable eventually to like check each other and then perhaps get to like more predictable stage and yeah.
Yeah, so I think it's a journey, I've seen this. So as I mentioned in my previous company, we were building remote control centers to take over autonomous vehicles when they fail. Okay, so not failure like an accident, but more like the car doesn't know what to do. It's optimized for safety, so it stops right in the middle of the road because it doesn't know what to do. And that's where we needed to bring human in from a control center in order to basically have the decision and release the autonomous vehicle to continue on its path. And our prediction was exactly based on what you're asking, like that, while at the time that we were working on it, about 20% of rides were reaching such a stop, and obviously, the amount of people in a control center you would need if this would continue to be the case would be, and autonomous vehicle were really adopted, you would need millions of people in control centers. It's not sustainable, right? But our prediction was that, the error rate will not remain at 20% of drives. Like as we progress, it'll go to 10% and 5%. And, as autonomous vehicles scale up, the percentage of error will go down, and we will eventually reach a sustainable model where a control center with like 200 people can control, I don't know, the Las Vegas territory. Yeah, so I definitely think that the error rates will go down. Will they go down to an absolute zero? Probably not, but I don't know, maybe. Time will tell, I guess. Yes, any more questions? Yes, sir.
Like cost-wise, what's kind of like the amount of resource you need to use to run this model constantly?
Yeah. Well, I think about the error rate in a similar way to the way I think about the costs, right? Because we saw that OpenAI trained a few very heavy-duty models, and then DeepSeek came in with much more efficient methods and much lower cost base. Now, there's really no way to know, right? Because this is like complete innovation, right? This is like, we're talking about the most frontier models. But I hope that, the trend of efficiency will continue. And if you look at, for example, semiconductors and processors, Moore's law, anyone not familiar with Moore's law? Okay, so Moore's law is like a historic prediction that one of the founders of Intel, I think Moore was one of the founders of Intel, and he predicted that every year and a half, semiconductors will become twice as smaller and will consume twice as much electricity. Am I wrong on the numbers? Every 4 years, yeah. Every 4 years, yes. So that's like an exponential improvement. And maybe, I should publish a post with like Saar's law that says that this will happen in AI as well, and people will quote me and there will be a rule of it. But I kind of believe that, this will be the case there as well. In Moore's law stopped a few years ago. Like we actually reached, such small size of semiconductors that we're starting to see like quantum effects, and there's like serious limitations in the physics of making it even smaller. So like Moore's law held for like almost 50 years, but then so I don't think anyone knows. Like with Moore's law, we didn't know that we will run into, in the 2010s or 20s, we will run into quantum physics, and it'll be that small, and that will be the limitation. In the same way, we don't know where will we hit the wall with AI, in terms of efficiency and performance and accuracy, etc. We just see the trend right now, and the trend right now seems like it will get cheaper, it will get more accurate, it will get smarter, but where is it going to stop? I don't think anyone knows. There are rumors that, Sam Altman and the CEO of NVIDIA, Jason Wang, like that, basically I follow, what they say, because if someone would know, it's them. Like, if someone would know, it will be the CEO of Microsoft, the CEO of Google, the CEO of OpenAI, and the CEO of NVIDIA. If we are, they will be the first to know when we hit that wall. So just read the news, read between the lines on what they are saying, and you'll figure out how far are we from that, from hitting that efficiency wall and accuracy wall. Like, yeah. Okay. Yes, I think Ethan, you last question.
Last question.
Okay. Yeah.
I really like the view of the high abstraction, but I have like kind of vague view of it. For example, what would be bigger in the higher abstraction? Would it be like a business logic of education, or do you mean by like AI society or AI constitution?
Yeah. So we believe in no code. So you can think about it as systems like Zapier, where you can chain actions with different systems and label them. So you have like get, I don't know, once you received an email, analyze that email with ChatGPT. With the result, create a script for social video. Then with Midjourney, generate an image for that video. Now send it to me in Slack and let me choose which image I want to produce video with. And then you press, okay, I like option B. And so people are building these kind of workflows today for marketing, for many other things, and we believe in it for engineering as well. We believe that it's the next level of abstraction that is required at the age of AI, where AI can produce a lot of content, but needs to explain it to us dum-dums, basically. So,
AI human interaction.
Yep.
AI.
Yes, exactly. Abstraction is needed for us to understand things more than it's required for AI, I think. Yeah. Okay, thank you so much. Thank you for all your questions and your engagement.